All right, let's do this one. So Marie paddles a canoe due north at 7 meters per second. So what does this mean? So when she's paddling, she's going due north. So I'm going to say 7 meters per second. This is her velocity vector. Where, remember, this is north, east. Never eat shredded wheat, right? All right, so then the river flows due west at 3 meters per second. Yes. Oh, wrong way, I know. I did that on purpose to see if you're paying attention. West is the other way, right? West is this way. All right, so it says, what angle does the canoe travel at? So you could think of this a couple of ways, and we haven't done west or east or whatever, but we're trying to find this resultant vector. The resultant vector will look like this. And then we've got to figure out what the angle is. So this would be like theta right here, okay? Now, we tend to, remember, this is like velocity in the x direction. And this is like velocity in the y direction. So then to find the angle between the two, you would need to remember, and it's in your notes, but theta is equal to arctan of Vy over Vx. Right?
Bless you.
Thank you. Oh, by the way, that's not just 3, isn't it? It is what, 3?
Meters per second.
It's negative 3. Okay.
Oh, this is going left.
Yeah. So now, the negative 3, so this is an interesting thing. If I plug in the negative 3, it's going to give me an angle. If I plug in 3, it's going to give me a different angle. So we'll circle back to that in a second. All right. We have to think about the relativeness of how we measure the angle, right? So, in other words, this will have a term. So let's just finish this first, and then we'll go from there. So this is equal to arctan. Now, if I plug in, the question that I'm thinking about is, do I do positive 3 or negative 3? They're going to be the same value, but one will yield a negative and the other will yield a positive. Yes?
7/3.
Is it 7/3? You're absolutely correct. Well, hold on a second. Normally we would do it that way, but are we going to... So your answer is saying relative to north. So really what we should do, and I didn't read that at first, if we say relative to north, you're kind of rotating it. Usually when we do this type of math, we say relative to the x-axis, right? So all that math is like relative to the x-axis. And so what we're doing is we're going to arbitrarily change that. So I want you guys to kind of think in terms like this. Relative to north means that we would be relative to the x-axis, because all the math works. So this is where we're going to get weird. This will be the positive x direction. This will be the negative x direction. This will be the positive y direction. And this will be the negative y direction. We can arbitrarily choose whatever we want. But when we do angles, remember from your geometry days?
Yes.
When we measure an angle, it's relative to the x-axis. So here's our x-axis. And really, essentially what we're trying to say is, oops. What we're trying to see is, what would this angle be right here, theta? Okay? So then I have to rethink about the negative and positive, right? So if I think of that, I don't know which is easier. This would actually be v sub y, but now because we've rotated the x-axis, that's in the positive 3 direction, right? Because we're rotating our axis, and y would be 7. So this over here, so then I have this set up properly because we rotated our axis. So the numbers are right, but now I've got to go back and make this a positive 3. That's where I was getting to. It just took me a second to get there. All right, so now let's plug this in our calculator. We'll use the scientific calculator. And if you go to functions and hit arctan, and I'm just going to do, what was it, 3 over 7? 3 divided by 7. It's about 23.2 degrees. So what we found was, oops. But that's going this way, right? So when I'm measuring that angle, I'm measuring this way. So if this is north, and this is east, and this is south, and this is west, how would we word that? Well, go ahead. What do you think?
23 degree west of north.
Yep. West of north.